You may have heard of the Hubble telescope. That's a telescope that's above the Earth's atmosphere that takes wonderful clear pictures of the universe. Well, it was named for a famous astronomer, Edwin Hubble, and he's noted for two major discoveries among other things. And here they are. First, there are other galaxies besides our own Milky Way. And since all these galaxies are moving away from us, the universe must be expanding. We need some evidence for that expanding universe, and one of the pieces of evidence is something called redshift. We talked about the light prints, and one thing you should know is the red end of the spectrum has longer wavelengths, lower energy, whereas the violet end of the spectrum has shorter wavelengths and therefore higher energy. We can detect light with a spectroscope to get our light prints. And what happens is they found that when they look at the spectrum of stars, they're actually shifted towards the red end. In other words, if the star wasn't moving away from us here on Earth, we'd see its color, like for hydrogen and helium, it would look like a regular light print that we'd see. But if the stars are moving away, all those color bands are shifted towards the red end. Well, why is that? Well, if they're moving away from us, the wavelengths of light when they arrive here at Earth are longer or lower energy, and that means it has to be an expanding universe. And the faster a galaxy is moving away from us, the more the color gets shifted towards the red end of the spectrum. Now, if it's possible to go back in time, if we have an expanding universe, and when you go forward in time, it gets farther and farther apart, going back in time, all the stars, galaxies would be getting closer together. And from calculations, they can see where they would have all started at one point, an incredibly dense point of matter and energy, and that was 13.7 billion years ago. And you may have heard of the Big Bang Theory, and this is the idea that all of the matter and energy was concentrated to an insanely dense mass that for some reason exploded and sent all this matter and energy outwards, and it's been doing so for 13.7 billion years. When you see a star at night, you are looking back in time. That photon is going to hit your eye and then transform to a different form, but it will have been traveling all that time. So the farther away a star is, the longer its light took to reach your eyes. And we know it takes 8 minutes for sunlight to reach us here on Earth. So when you watch a sunset, the sun will have set by the time you actually see the sunset. In a future video, you're going to learn about this cosmic background radiation from the Big Bang. And here are two other pieces of equipment. We have something called the COBE, the COBE, Cosmic Background Explorer Satellite. And we have the WMAP. And we'll touch on those things later on. They both gave key pieces of information in our study of astronomy. So that's it for 13.1.